Now, if we're going to convert fractions, we've got to talk about something called the least common denominator. We want to find a number that all the other denominators can be evenly divided into. We want it to be the smallest number. That's why we call it the least common denominator. So here's a way you can do this if the numbers are not readily apparent. And I've written the steps for you at the top of this page. First, you would factor each denominator to primes. Second, you would circle the greatest occurrence of each number in the factorizations. And 3, you'd multiply the circled numbers. I'll show you what I mean with the example number 1. We're only working with denominators here, so we're only concerned with the 9 and the 15. I want to factor both of them to primes. Well, 9 factored to primes is equal to 3 times 3. You can use a factor tree if you need to, but I think you can see that. 15 is equal to 3 times 5. So I've got both of my denominators factored to primes. Now step 2 says circle the greatest occurrence of each number. Well, I've got 3s and I've got 5s in the factorization, and in 9 I have 2 3s, so that's the greatest occurrence. I've got 2 3s here, I only had 1 3 in the other. How many 5s do I have? Well, the greatest occurrence of 5 is just the 1 that's in the 15, so I've got that. You see, the extra number I have that I don't need to use is this extra 3, okay? So what do I do when I say my least common denominator? I multiply the circled numbers. 3 times 3 times 5 gives me a denominator of 9 times 5, or 45. The LCD, or the least common denominator for those two fractions, would be 45. Let's try it again with another set of numbers, 36 and 24, in example 2. Now, one of these numbers is negative, but when we're doing LCD, we don't have to worry about that negative. We just want to worry about the factors of 36, which I'm going to have to factor. I'm going to say prime factors of 36. Let's see, 2 times 18, and 2 times 9, and 3 times 3. Those are the prime factors of 36. We've done this before. So 36, I'll write it up here, is equal to 2 times 2 times 3 times 3. What about 24? I can factor that to 2 times 12, and 12 I can factor to 2 times 6, and 6 I can factor to 2 times 3. Okay, let's write it down. 24 is equal to 2 times 2 times 2 times 3. All right, now I want to circle the greatest occurrence of each number in my factorizations. Well, in my factorizations of 36 and 24, I have 2s and I have 3s. In 36, I have 2 2s, and in 24, I have 3 2s. Well, the greatest occurrence is the 3 2s, so I'm going to circle those. What about the 3s? Well, in 36, 3 appears twice, but in 24, it only appears 1 time. The greatest occurrence is the 2. So the ones I need are the ones that are circled. The others are extras. For my least common denominator, I would use 3 of the 2s and 2 of the 3s. In other words, the LCD is going to be equal to, if I multiply 3 times 3 times 3, that's 8, times 3 times 2 times 2 is 2 is 8, times 3 times 3 is 9, 9 times 8 is 72. That is my least common denominator for 36 and 24. And what is that? It is the number that both 36 and 24 will evenly divide into, the smallest number. Okay, let's look at when we have 3 factors or 3 fractions that we're working with. We got a 4 in example 3, a 14, and a 20. Well, I can tell what 4 is. 4 is factored to primes. It's 2 times 2. 14, I know that one too. 14 is 2 times 7. And 20, maybe I can do 20 in my head because I've done this so much now. It's 4 times 5, but 4 factors into 2 times 2 times 5. So I can sort of do these in my head a little bit. Now I want the greatest occurrence. What numbers do I need to use? 2s and 7s and 5s. I've got 2 2s in 4, 1 in 14, and 2 in 20, or rather 20. Okay, so I've got 2s. I've got 2 2s used. That's the most it's ever used, so I'm going to use 2 of them. 7 is just used once, and 5 is just used once, and those extra 2s are just extra. Least common denominator, it's going to be 2 times 2 times 5 times 7. In other words, that would be 4. See, isn't it? 4 times 35. Least common denominator, if I can do that correctly, is going to be 140. I believe that's right. 2 times 2 times 5 times 7. All right, example 4. 3 numbers I'm working with, 25, 15 and 6. And remember, the negative doesn't really help us as far as least common denominator. We don't really use it for that. So 25, I know that one. Factors to prime, 5 times 5. 15, I know that one also. Factors to 3 times 5. And 6, the factors are 2 times 3. So the numbers I'll need are 5s and 3s and 2s. Well, the most 5s I'm going to need are used up here in 25. There's 2 of them. And the most 3s used in any one is just 1 3, and then there's just 1 2. That's the most used. So here's my LCD. It's equal to 2 times 3 times 5 times 5. 2 times 3, of course, is 6. 5 times 5 is 25, and I think 6 quarters is the way I usually think of that. So 6 times 25 with 6 quarters would be $1.50 or $150. So LCD is $1.50 for those 3 fractions. Now, why do we need that? Well, we want to convert some fractions. Let's say we have the fraction 5/6, but we need it to be the same fraction or equivalent fraction with a denominator of 24, as in example 5. I put some space between my fraction and my equal sign, my first one, because I want to show you what we have to do when we convert. Basically, what we want to do is say, what would I multiply times 6 to get 24? And the answer is 4. If I multiply the denominator times 4, I also have to multiply the numerator times 4. And it would be 20 over 24. And the reason is this. If I multiply that fraction times 4 over 4, I'm really just multiplying it times the number 1. And when I multiply anything times the number 1, it doesn't change its value. All I'm doing is changing the terms that the fraction is represented in. So 5 over 6 and 20 over 24 are what we call equivalent fractions. Let's look at example number 6. I have a denominator of 2, and I want to change it to a denominator of 12. So I'd multiply times 6. Therefore, I have to multiply that numerator times 6. 3x times 6 is going to give me 18x. My equivalent fraction, 18x over 12. Number 7, I have a 7/6. I need it to have a denominator of 36a. So what do I multiply times 6 to get 36a? Well, I'll have to use 6a, won't I? So I'll use 6a in the numerator also, and that gives me a numerator of 42a. So 42a over 36a is my equivalent fraction. For number 8, I've got a denominator of 15. I want it to be 60. 15 times 4 will give me 60. So I must multiply the numerator times the same thing. The numerator of 4x times 4 is 16x. So it would be 16x over 60 would be my equivalent fraction.